This is my bus sniffing FX702P. There's an FX702P with no display. Turn it on and off. The keyboard is wired up, the on-off switch is wired up, but I've got a blue pill here which is doing the bus sniffing. So if I type stuff, if I go into mode 1, you can see that the mode 1 display appears, and back to mode 0 and do a calculation, and you can see that it's all working here. And some of the enunciators, well, most of it is all displayed. I did have trouble with, I think it was hyperbolic shift or something here, couldn't get that to display. So if I do an F1 hype, it doesn't actually appear because I couldn't find out where that was in the traffic that's going to the display controllers. I think now maybe I can sort that out with some other information that I've got, but anyway, that's not really what we're looking at here. So I've bought 2 or 3 FX702Ps. The first one was a real basket case, the display didn't work, and that is this one here, where I took the display off, did the bus sniffing so that I could get a display and actually use the 702P. That's fine, but this is a little bit inconvenient to use, and I wanted one that was in the original form factor, so I got another one, and that was a really nice case. That's this one here. It was, I mean, it's basically it's basically almost mint. It's really nice, and the display was nice, still is nice. Unfortunately, you couldn't enter programs on it, and you can see here that I've done my usual chopping things about. So I thought the RAM was actually faulty. This is the RAM PCB, and you can see there's 4, what are they, D444Gs. They're 1024 by 4-bit RAMs, and there's 4 of them, so you've got 2k bytes of RAM there, and then other little bits of circuitry. And basically that just sits on a bus and is the program and variable space for the 702P. So I thought that was failed because I couldn't enter programs. I could do everything else, but I couldn't enter programs, and variables didn't work, so it looked very much like this was broken. So I actually took the chips off, and the board on the back of the bus sniffing setup is actually got no chips on it. It's actually empty, and I've got this Raspberry Pi Pico here and a lot of wires emulating the entire 2k of RAM. The 4 chips are emulated by that device there. I've also got it running off USB. I need a USB for the blue pill, and I need a USB here for the Raspberry Pi Pico, and I need a supply for the 702P. So I'm running off USB so that I have 5 volts on the internal supply of the 702 rather than 6 volt battery voltage. So it can run from 4 to 6 volts. 5 volts is fine for the Pico, 6 is not. So I'm running off USB. Because of the way that these two, the blue pill and the Raspberry Pi Pico, these two devices are wired up internally in the 702, they're actually running off different grounds, so I have to run the 2 devices off different supplies, which is a bit of a pain. I've got one off a wall wart, another one off my laptop. But it does work. If I say S equals a few 1s, and then I display S, I get back a few 1s. Now that's being displayed in the memory of the Pico. If we go to mode 1 and I enter 10, T equals 1, 2, 3, 4, and I'm only doing the T equals because it's a quick command to do. And then if we do a list on the keyboard, there you go, T equals 1, 2, 3, 4. If we go back to mode 0, what's in T? 0 or nothing. There's no decimal point there, so it doesn't actually exist. If we run the program with P0 and then have a look in T, 1, 2, 3, 4. So it's working. And if you look on the serial interface on the USB of the Pico, we can actually look at the emulation RAM. That's the emulation RAM. If we go up the top, this, it turns out at the top here is the keyboard buffer, and then it compiles that into key codes in here. And what do we have here? There's 1, 2, 3, 4. That's the first memory, I think, there. And on, where is it? Somewhere around here is the dollar variable. So I've managed to find out a little bit about the memory layout. So if we put A, B, C, D, E into the dollar variable, and then have a look and see what's in it, A, B, C, D, E, and then do another dump of the memory, you've got A, B, C, D, E here, coded as, well, it's close to ASCII, but it's not actually ASCII. The program entry, actually no, I think the program entry is here. So this is the T equals 1, 2, 3, 4 here, and T itself is actually here, down at the other end of memory. So that's all nice, that works, that's fine, everything's lovely. And I've got some other options in the menu. I can actually save and load the memory to and from RAM, and I can also erase from flash. That's the onboard flash of the P code, just like I did with the FX702P and the Pro 101. It's sort of based on the same code, very similar. Unfortunately, all three of those devices, the 702P, the 201 and the Pro 101, all use different RAM chips, and they're all completely different. So the code that actually does the emulation has to be different. But it does work, all three devices. Now the FX201 and Pro 101, the firmware in the calculators themselves actually just uses the external RAM for program storage, and it doesn't use any other information. Now the 702P isn't the same. So if I turn this off and back on, you can see that ready P0 has come up, and you do a mode 1 and you've got P0 there, and we do a list. There's the step. Now if I go over to my USB interface and I zero my parameter and type 200 in, I can now erase that slot in flash, have a look at it, zeros, which is actually FFs because the data is inverted on the 702P, it turns out. I can then save the data we've got at the moment, which is P0, having that line 10. If I then have a look at that slot, you can see that the data that we saw is now in flash. This is the flash data. You can see it's there. And now if I then go into mode 1 and I do a clear all, take a little while to type it in on this keyboard, clear all. Now that's cleared the program, so mode 1 has no program stored. I'm not entirely sure, does it clear the variables? I'm not sure if it does, it might do. No, it doesn't. So the variables are still there, but the program's gone. And it's really the program you're interested in, mostly. The variables, it'd be nice saving and loading those, but it's really the programs that are the interesting bit to save and load in flash. So if I go back to my USB interface and we have a look at the emulation memory, the strange thing is the program data P0 is still there. So if I go, we're still looking at actually no, parameter 200. If I display the data in parameter 200, it's what we had before. It looks very similar to what's in the emulation memory. If I load it back in, so I've loaded that now from flash into the emulation RAM, so we're back where we started when we had that program P0. Where is it? Here. We actually had that program. That's line 10. 53, I think it's T, and 1C is equals, and there's the 1, 2, 3, 4, and FF is line end marker. So the program is back. The emulation RAM is exactly as it was before, and if we go to mode 1 you can see there is no P0. So I think what's happening here is that the pointers that tell the 702P where the programs are not stored in the external RAM. They're stored in another one of those 4 devices on the main PCB. So we've got 2 display controllers here and 2 processors, and the processors talk to each other and the display controllers. Now there's ROM in the processors, there is ROM and RAM in the display controllers. I don't know if there's RAM in the processors. I sort of suspect there isn't, but there is some RAM somewhere where the pointers for the programs are stored. So even though I've restored the actual program itself, there's no way you can get to it, or no way I've found of getting to it through the keyboard or any other mechanism, fiddling with RAM in the emulation. There's no way I've found to get that program back, because I know there's a line there, line 10, but it's not shown here and I just can't execute it. So really that sort of puts a stop to this, because I can't save the programs to flash, and that's the sort of useful bit. Then you can save and load. You've got non-volatile storage and slots for program data, just like I did on the 201 and the Pro 101. So that's sort of a bit of a shame, really. It may be possible to, well, not sniff the traffic like I'm doing on the display here. I am looking at the traffic on the display controller, both of them, and reproducing the display. Now it may be possible, if the pointers are stored in the display controller RAM, it may be possible to, rather than sniff the bus, actually have a sort of man in the middle, receive data that's going to the display controller, and then alter it and write it back and so on, or read the data that's in there and store that in flash and then rewrite it when I rewrite the emulation RAM. Something. That's if the data is stored in the display chips and it can be intercepted in that way. So that's different code to the code I got on here. It may be possible to do it in the same Pico that I've got on the bus, because the data lines and the address lines are shared between the RAM and the sort of bus that is used to talk to the display controller and the processors, and also the external 7-pin socket. But it's, even though the address and data lines are the same, the protocol is different. It's using the OD and the SP, the sync lines and all that sort of stuff, which is what's going on here. So if it's stored in there, it might be possible to do it. If it isn't, then that's it really. You can't have the saving and loading of programs to and from flash. Now the memories, you can save and load those, because they're just stored in part of the emulation memory, and you can save and load those as much as you want, but that doesn't really give you the useful bit, the programs. So it's a bit of a shame. This project will probably go on hold again until I sort of get up the enthusiasm to do a bit more reverse engineering on the protocol, and see whether I can do a man in the middle sort of interception of the traffic in both directions, which is more complicated than just monitoring it like I'm doing here. It should be possible, but it's just more involved, and it will require quite a few GPIOs, so I probably can't do it on the same Pico as we've got here. This does work as a RAM fix, so if you've got a bad RAM board, this one here, it does replace the RAM board, but obviously using the Pico it's not low power, so you don't get any of the advantages of low power. It doesn't replace this entirely, so you probably want to put a low power CMOS RAM chip on to replace these devices. The thing with that, even if you put a larger capacity RAM chip on, which you'd have to do, you can't really use it. You can't switch another bank of RAM in, because the program's indexes are stored in some other area, so you've got the same problem. All you'd be able to do would be to fix a broken RAM chip, and that's about it really. So even you'd have a low power system and you'd be able to run it off batteries on that, but yeah, same problem really, even if you replace it with a RAM chip. So that's the state of the 702P project. Display works, although with all this hanging off the bus I do get corruption on the display occasionally, so that's not really a problem. I think it's just the wires or something that I've got there. They're extremely long. I mean, they're about, you know, inches long, which isn't really what you want. Most of the time it's alright though. But yeah, there we go. All a bit of a shame really. So I can't do what I did on the FX201 and the Pro 101 on the 702 because it doesn't store its entirety of the programs in the external memory.